Section 7.6, Trigonometric Equations. In this section, we discuss trigonometric equations. That is, equations involving trigonometric functions that are satisfied only by some values of the variable, or it's possible that they're not satisfied by any values of the variable. All right, the equations that you see in this section are going to be in stark contrast to those we saw in section 7.2 where we were verifying identities. When you have an identity, that is an equation, but it's true for every single value of the variable. It's always true. So the equations that we're going to see in this section are going to be conditional equations, meaning that they're true for only some values of the variable. And it's possible that they're never true, meaning that your equation will have no solution. Okay? So our goal here is going to be to solve these equations, find the value or values of the variable that do make the equations true. Okay, if you read in the second bullet point here, it says the values that satisfy the equation are called solutions of the equation. Unless the domain of the variable is restricted, we need to find all the solutions of a trigonometric equation. Okay, so how do we do that? Because we know that trig functions are cyclic, they repeat. So if an equation does have a solution, it's probably going to have several solutions. So if you read the blueprint there, it says finding all the solutions can be accomplished by first finding solutions over an interval whose length equals one period of the function, and then adding multiples of that period to the solutions found. Okay, so that's a very important statement. That's why it's in blue. I will read through it again, but like I said, we're going to get a lot of practice. This statement will make a lot more sense when we're actually doing the solution process. Okay, but again, to find all the solutions, what you're going to do is first find solutions over an interval whose length equals the period of the function. And then once you have those solutions, you're going to add multiples of that period to the solutions found. And that will get you all the solutions. Okay, so in reading this blue statement, obviously you're going to need to know the period of your trigonometric function. So you need to remember what those are. Okay, so I've got a little box here where we can just jot down the period of each trigonometric function. Remember what the period of a trigonometric function is. It's very much tied to the graph of the function. It is the length of time that it takes to complete one wave. Okay, so the length of one wave or cycle. Okay, that is what that means. Okay, so if you need to go back and look at a graph, you can do that, but I'm just going to tell you what it is. The sine function has a period of 2 pi radians. I'm going to list these in terms of radian measure, but you could do the same thing for degrees. I guess I can put it right here. I'll put the degree down here. Okay, so for sine, if you have a sine function, okay, the period is 2 pi radians or 360 degrees. Okay, because cosecant is just 1 over sine, cosecant has the same period as sine. So I'm just going to write the same thing down for it. Okay, and then if we jump to cosine, it takes also 2 pi radians to complete one wave or cycle, which is 360 degrees. And then same thing, secant is 1 over cosine, so it's going to have the same period. The only two that are going to be different are tangent and cotangent. To complete one cycle of tangent, it only takes pi radians or 180 degrees. And so then cotangent is 1 over tangent, so it will have the same period. Okay, so keep these in mind if you've forgotten them. Okay. All right, what else should you know about solving trigonometric equations? Well, it says when solving trigonometric equations, you really should write your answers using exact values rather than decimal approximations. However, sometimes an exact value is not possible, and then it will be okay to write your answers as decimals. Okay? In this section, we will learn methods for solving the following types of trigonometric equations. So what I have here is a list of the types of equations we're going to go through, and then underneath each type, I've got an outline of the methods you can use to solve these specific types. Okay, so the first type of trigonometric equation we're going to look at is a linear trigonometric equation. So the methods you can use to solve that type of trigonometric equation, you can either isolate the trigonometric term, or factoring may work. And then we're going to take a look at quadratic equations. Okay, there are three different things you can try there. Okay, you can factor, extract square roots, or use the quadratic formula. Okay, the next type of trigonometric equation we will look at, that's equations involving more than one trigonometric function. Okay, so what I mean by that, just to be clear, equations involving more than one trigonometric function. Okay, so your equation might have a sine and a cosine, for example. Okay, or your equation might have a tangent and a secant. It's not just one type of trigonometric function. Okay, when I say equation with one type of trigonometric function, that means it's going to have all sines, or it's going to have all cosines. Okay, but now it's definitely possible to have an equation that has more than one type of trigonometric function in it. So in that case, what you can do, you can either use a known identity to make a trigonometric substitution, or another method is to square both sides, which is kind of an unusual method, something you may or may not have done before. But that will work. And if you do use this method where you're squaring both sides, you need to be sure to check your solutions, because the process of squaring both sides can produce extraneous solutions, which means you might get something that looks like it is a solution, but then if you plug it back into the original equation, it doesn't work, so you have to get rid of it. Okay. All right, the last type of trigonometric equations we will encounter are trigonometric equations in which the argument is not exactly theta. So what I mean by this, okay, for example, this could be a half angle. Okay, so you might see theta over 2 instead of theta. It could be a double angle. Okay, so 2 theta. It could be a multiple angle. So maybe 4 theta. Another thing it could be is some kind of transformation. Okay, transformations, those are basically shifts in your graph. So your graph might be shifted horizontally left or right, for example. And in that case, you might see something like this, the cosine of theta minus pi over 2. Okay, so the argument here would be theta minus pi over 2 instead of just theta. So you have to know how to deal with that as well. Okay, so if you encounter an equation like this where the argument is not exactly theta, there's a couple of things you can try. First, you can make something called a u substitution. What you're going to do is substitute the variable u for the argument. You're going to solve the equation for u, then you're going to replace u with the original argument, and then solve for the original argument. Okay, the other thing you can try is to use a known identity to make a trigonometric substitution. Okay, we are going to go through the types of equations in this order. Okay, you're going to see all the different methods that can be applied. Okay, so this page is really just a summary. If you know you are stuck on an equation, you can flip back here, try to identify it as one of the types, and then recognize a method you can use to solve it. Okay, if you don't quite understand what I'm talking about here in terms of the methods, that's okay. Like I said, we're going to go one equation type at a time and work on each of the methods. So hopefully it will make sense after that. Okay, so let's get started on linear trigonometric equations.